Dear students, in the previous video we have learnt about chemical reaction. What is chemical reaction? Chemical equation, skeletal equation, balanced chemical equation, then characteristics of a chemical reaction, and we have also learnt exothermic reaction and endothermic reaction. If the heat is liberated during the reaction, it is termed as exothermic, and if the heat is absorbed, it is termed as endothermic. So these things we have learnt in our previous class. Today, with the help of this video, let us learn types of chemical reaction. Basically, how the reactants react and how the products are formed. The types of chemical reactions are of following types. The first one, combination reaction. Second, decomposition reaction. Third, displacement reaction. Fourth, double displacement reaction. Fifth, oxidation and reduction reaction. These are the types of chemical reactions in your syllabus that you are going to learn this year. These are the types of chemical reaction: combination reaction, decomposition reaction, double displacement reaction, double displacement reaction, oxidation and reduction reaction. So let us learn one by one in detail. First one is combination reaction. Observe this video here. Observe this image here. Here you can see that magnesium ribbon is taken with the help of tongs. It is burnt. So when magnesium ribbon is burnt, this magnesium combines with oxygen and it forms magnesium oxide. So here what do we observe? A reaction in which two or more reactants combine to give single product is called a combination reaction. Can you tell me which are the two reactants here? Yes. Two reactants in this experiment, in this reaction is magnesium and oxygen. You can observe here magnesium ribbon. It is burning by taking the oxygen from the surrounding. So magnesium and oxygen are combining together and it is giving the product magnesium oxide. So here we see that two reactants are combining and giving rise to one single product, which we collect it as ash. So this is nothing but magnesium oxide. So we have observed that two reactants have combined here. So such a type of reaction in which two or more reactants combine to give a single product is termed as combination reaction. Let us see few more examples. Observe this image. Carbon, you all know that carbon plus oxygen. Here carbon is combining with oxygen and it is giving rise to CO2, carbon dioxide. So here we see that two reactants are combining to give rise to single product, that is carbon dioxide. So this is an example for combination reaction. Let us take one more example. Learn few more examples here. Hydrogen. We know that hydrogen is highly inflammable gas and oxygen is a supporter of combustion. When these two reactants combine, it gives rise to water, H2O. So water is used to extinguish the fire. Already we have learned in our previous classes that this product, the product which are formed here are having completely new characteristics. Hydrogen, oxygen. Both are gaseous in nature. Hydrogen is highly inflammable gas. Oxygen supports the combustion. But when these two are combining, we get the product with new characteristic that is used to extinguish the fire, to put off the fire. So here two reactants are combining to give one product, that is water. So this is an example for combination reaction. Let us move on for the next one. Take some examples. Already you have seen this. Carbon and oxygen combine to give carbon dioxide. How many reactants are here? 2 reactants. How many products? 1 product. So 2 reactants combine to give single product. Take one more example. Hydrogen, chlorine. So hydrogen gas and chlorine gas are combining together to give rise to hydrochloric acid, HCl. So here we get 1 product. Take one more example. Sodium combines with chlorine and gives rise to sodium chloride. Take one more example. Iron combines with sulfur and give rise to iron sulfide. Here, calcium oxide, it is a compound. So this compound is combining with one more compound, that is water, and it is giving rise to single product, that is calcium hydroxide. CaO, calcium oxide, reacts with water, H2O, and it gives rise to calcium hydroxide. Here how many reactants are there? Yeah, 2 reactants are combining to give rise to single product. So this is also an example for combination reaction. Take one more example. Ammonia, NH3, reacts with hydrochloric acid, HCl. Here 2 compounds are there, ammonia and hydrochloric acid. These 2 compounds combine to give rise to single product compound, that is ammonium chloride. Take one more example. Carbon monoxide. This is a compound. So this compound reacts with oxygen, O2, and gives rise to carbon dioxide. The product is single. Again one more example. Sulfur dioxide reacts with oxygen. 2 reactants combine and give rise to single product, sulfur trioxide. Next, till now we have learnt about combination reactions. Now let us move on for the next type of reaction, that is decomposition reaction. Consider this example here. What do you see in this equation? Calcium carbonate, CaCO3. CaCO3 is the formula of calcium carbonate. This is a compound, calcium carbonate. So this compound, this is a single compound. So this compound is decomposing, dividing, and it is giving rise to 2 products, calcium oxide and carbon dioxide. So just try to relate this equation with the previous reaction, this reaction with the previous combination reaction. There in combination reaction we have seen that 2 reactants combine and give rise to a single product. But here what do we see? Single reactant is giving rise to two products. It can be 2 or more also. But in this case, single reactant is giving rise to 2 products. So such a type of reaction where a single reactant give rise to 2 or more products is known as decomposition reaction. Let us take one more example here. This is an example for decomposition reaction. As you can see in this image, AB gives rise to A and B. Here you can see this motion pictures, images here. This is the compound potassium chlorate. This is potassium chlorate. See how this potassium chlorate is dividing itself and it is giving rise to, right, potassium chloride and oxygen gets separated. KCl and O2, 2O2. Oxygen is getting separated. So potassium chlorate undergoes decomposition, separation, and it gives rise to potassium chloride and oxygen. So here single reactant is giving rise to 2 different products. So this is again an example for decomposition reaction. Let us learn more with few more examples. Yeah, quite interesting. Here you can see a small volcano. This is very interesting. In the lab we have done this experiment, right children? You might have remembered. This is ammonium dichromate. What you see in this petri dish is ammonium dichromate. Just a slight ignition of this ammonium dichromate will give us a beautiful volcano. So what is the chemistry behind this? Let us learn now. So here we see that just now you have seen a small volcano. What is the reaction taking place is here. Ammonium dichromate, on heating it is decomposing. It is decomposing, dividing, and it is giving rise to nitrogen, water vapor and chromium 3 oxide. So here again we can move back to the same and watch it again. Here we have taken ammonium dichromate. As soon as we apply a little bit of heat and we ignite it, it starts burning. And do you notice the gas here? Yes, the gas liberating here is nothing but nitrogen. And water vapors are also coming out. And the solid black deposition here, what you see, which is oozing out, is nothing but chromium 3 oxide. So here, how many reactants are there? Can you tell me how many reactants is there? Yes, the reactant is only one. That is ammonium dichromate. Ammonium dichromate is a single reactant. But this single reactant is dividing. It is getting decomposed and giving rise to how many products can you count here? Nitrogen, water vapor, water and chromium 3 oxide. So here we are getting 3 products from a single reactant. So such a type of reaction where single reactant give rise to more product, 2 or more product, is termed as decomposition reaction. Observe in this video how the decomposition separation is taking place. Let us move on for the next example and learn what is decomposition reaction. So the reaction in which a compound splits up into 2 or more simpler substances are known as decomposition reaction. The decomposition reactions are carried out by applying heat, light or electricity. So this decomposition, what you have seen, reactions what you have seen in the previous images or slides, that doesn't happen on its own. Either it should be subjected to heat, or it should be subjected to light, or it should be subjected to electricity. So when we subject this reactants to heat, light or electricity, they decompose, they get separated, and this is all about decomposition reaction. So based on whether we are applying heat, whether we are applying light or electricity, this decomposition reaction can be classified into 3. The first type is thermal decomposition. As the name itself indicates, thermal. Thermal is heat. The decomposition that takes place in the presence of heat is termed as thermal decomposition. Let us see the example for thermal decomposition. Potassium chlorate, on subjecting to heat, when we apply heat for this, when we heat this, it decomposes and gives rise to potassium chloride and oxygen. Recall this, already you have seen this decomposition in the beginning of this video. Let us consider one more example. If we take ferrous sulfate crystals in the test tube and if we heat it, ferrous sulfate decomposes to give rise to ferrous oxide and sulfur dioxide and sulfur trioxide. Iron oxide, sulfur dioxide and sulfur trioxide. Lead nitrate. When we take lead nitrate in a test tube and when we heat it, it gives rise to lead oxide, nitrogen dioxide and oxygen. What do you observe in all these reactions? So here single reactant is giving rise to 2 or more product. In the first case we are getting 2 product. In the second case, ferrous sulfate case, we are getting 3 products. In lead nitrate case we are getting 3 products. So this is an example for decomposition reaction. Electro decomposition reaction. So electro decomposition is a type of decomposition reaction which takes place in the presence of current, electricity. Let us take the example. So water. When we take water in a trough and if we pass the current, we can see water separates to hydrogen and oxygen. Hydrogen gas and oxygen gas can be collected, can be separated from water. So this is happening by electricity. This can be done by using electricity, electric current. So such a type of decomposition, separation that occurs with the help of electric current is called as electro decomposition. Take one more example. Sodium chloride can be separated, can be decomposed by passing the current, and we get sodium and chlorine. Take one more example. Aluminium oxide can be separated, can be decomposed by passing current, by subjecting it to current, and we can get aluminium and oxygen. Here is how the separation takes place. We have taken water, you can observe in this picture, we have taken water in the trough and we have taken battery, and the battery is connected to the electrodes here. Electrodes, graphite rods is taken, and as we pass the current, when the switch is on, the current starts passing and this water gets separated and hydrogen and oxygen is formed here. So here H2O is separating and it is forming hydrogen and oxygen. Hydrogen gas is collected in one test tube and oxygen gas is collected in another test tube. This is very important diagram from the examination point of view, children. This diagram can be asked for 2 or 3 marks in the exam. This is electrolysis of water. Schematic diagram showing electrolysis of water. So this is very simple diagram. Here we have taken a mug in which contains water, and with the help of pins we are inserting the graphite rods here, and we are trying to, we have kept the inverted test tube over it, and these pins or electrodes are connected to the battery. So as you can see here, 2 terminals are there, anode and cathode. So cathode is a negative terminal, anode is a positive terminal. So oxygen gas collects here in the positive terminal, the test tube that is having graphite rod which is connected to positive terminal, and hydrogen gas collects over the test tube which is connected to cathode, that is negative terminal of a battery. So very simple diagram, very easy, you can draw it very nicely. So write this and practice this for 2 or 3 times, you can do it. Right, next we will go for the same type of experiment. I find it very interesting, so I wanted this to share with you. Electrolysis of water experiment. Very interesting experiment. Most of my students have done this, and you can also try this at home. Since you are at home now, take the simple materials like plastic glass, 2 pencils and a battery, and try to make the arrangement as it is shown in the image here, and you can see bubbles of hydrogen and oxygen getting collected. Bubbles of hydrogen get collect over the negative terminal, and bubbles of oxygen you can see to the positive terminal. So this is a simple electrolysis of water experiment. Yes, go ahead and try to do this and share your video with me. Next, now we are going to learn one more type of decomposition. Till now we have learned 2 types of decomposition. One is thermal decomposition, second one is electro decomposition. Now we are going to see about photo decomposition. What is photo decomposition? As the name itself indicates, photo means light. The decomposition that takes place in the presence of light is known as photo decomposition. So here are few simple examples for photo decomposition. You can see here one reactant. What is the reactant here? Silver chloride. So silver chloride, when it is subjected to light, it undergoes decomposition and gives rise to silver and chlorine gas. So here a single reactant is decomposing and giving rise to two products. Single reactant giving rise to two products. So here photo decomposition is taking place. Let us take one more example. In the same way, silver bromide. Silver bromide on subjecting to photo, that is light, it separates, it divides and give rise to silver and bromine gas. So these are the example for photo decomposition. Here again you can learn more from this picture. In this plate, silver bromide is taken. Observe the color. What is the color of this? Light yellow in color. So when you keep this in sunlight for some time, this turns grey color. So what is happening here? Simple photo decomposition. Silver bromide in the presence of sunlight is decomposing to silver and bromine. Since bromine is a gas, it evolves. What is left over, solid left over here is nothing but silver metal. Next, till now we have learnt about combination reaction and decomposition reaction. Let us move on for the third type of reaction, that is displacement reaction. Displacement reaction. So what is this displacement reaction? Very nice interesting cartoon here. You can see hydrogen and sulfate. Hydrogen is sitting on the sulfate chair. So what this zinc has done? It has come, it has displaced hydrogen from its place and it has occupied the place of hydrogen. Just now observe here, zinc is asking hydrogen to get up. And now zinc is displacing hydrogen and zinc is occupying the place of hydrogen. So what has happened here? Zinc has reacted with sulfuric acid and it has displaced the hydrogen from sulfuric acid, H2SO4. It has displaced hydrogen and it has occupied the place to form zinc sulfate. Zinc sulfate, and the hydrogen gas is liberated out. So quite interesting, isn't it? So let us see few more examples of this displacement reaction. Observe one more image here. See, now you have seen copper and sulfate live together. Copper, sulfate. Now what has happened? As soon as the zinc has come there, it has provided it electron to copper. Copper has taken the electrons, accepted the electron, and it has reduced to copper atom. Now zinc has got the opportunity to combine with sulfate. Both are ions now. Zinc combined with sulfate and it forms zinc sulfate. So here, who is displacing what? What is displacing what? Yes, you might have guessed right. Zinc has displayed copper from its compound. See, now both are together. Now zinc has come. It is displacing copper and then zinc occupies the place of copper. So, can you tell me who is more reactive here? Yeah, zinc has come. Copper is separated. So, zinc is more reactive than copper. So, such a type of reaction where one atom or ion displaces the other ion or atom is termed as displacement. The reaction in which one element displaces the other element is known as displacement reaction. Now, it becomes very important for us to learn which element is more reactive and which element is less reactive. As now we have seen in the previous two images here, you have seen zinc and copper, and in this image you have seen zinc and hydrogen. Now with this image we come to know that zinc is more reactive than hydrogen. In this image we have seen that zinc is more reactive than copper. Then let us learn the series of the elements which is more reactive than the other. So this we can learn with the help of the series called reactivity series. So reactivity series is the serial arrangement of elements based on its decreasing order of arrangement of elements based on its reactivity or activity. The arrangement of elements based on the decreasing activity is known as reactivity series. The arrangement of elements based on their decreasing activity is termed as reactivity series. So here the first reactive element is potassium. It has come in the first place. Second is sodium. Third is calcium. Fourth is magnesium. Fifth is aluminium. Sixth, zinc. Then iron. Then tin. Then lead. Then hydrogen. Then copper. Then mercury. Then silver. Then gold. You have seen here, these are the series of elements that is arranged based on the decreasing order of their activity. So such a series is termed as reactivity series. Now through this series we can easily identify which element is more reactive and which element is less reactive. When two elements are compared, we can easily find out which element is more reactive and which element is less reactive. Let us test now. Now potassium and sodium. Can you tell me out of these two which is more reactive? Obviously it is potassium. Why? Because it occupies the first place in the reactivity series. Sodium comes below potassium, so sodium is less reactive. If we compare sodium and calcium, which is more reactive? Sodium is more reactive than calcium. In the same way, if we compare zinc and copper, can you tell me which is more reactive here? Yeah, zinc is more reactive than copper. I think now you have understood why in the previous image zinc has displaced copper. So zinc is lying above in the reactivity series. The place of zinc is above copper in the reactivity series. So whichever element lies above, and it can displace the element which comes below. So if we consider copper and silver, which is more reactive? Yes, copper is more reactive than silver. Why? Because in the reactivity series, copper lies above silver. So this is very important series and you can easily remember this. I have one simple, you consider it as song or any saying. I remember this in this way. I like to share it with you. Ka na ka mag alzen fes pep huku ha. Here ka potassium, na ka na sodium, ka na ka mag alzen fes fe iron, sn is tin, then feb pb lead, that is for symbols. I have taken symbols for remembering it easily. Pep, huku ha, hu h is hydrogen, hu ku copper, ha means H for mercury, silver, gold. Kanaka, magazine, fes, pep, huku, ha. In this way, I remember the reactivity series and I tell you children, it is really very interesting and it doesn't make any mistake. You can easily practice this and remember it. So this is all about reactivity series. Now I hope you have understood which element can displace which element. So the element that comes above can displace the element which lies below that particular element. So this is all about reactivity series. Let us move on for the next one. The next type of reaction, here again displacement reaction. Here you can see one more image I have taken. This is copper sulfate. Iron is coming now. It is displacing copper from copper sulfate. So iron can displace copper from copper sulfate and you can get ferrous sulfate. Now this is ferrous sulfate and copper can be separated. Now copper is separating. So this is again a displacement reaction. What is displacement reaction? You may get this simple questions in the exam. So those reactions in which one element takes the place of another element in a compound are known as displacement reactions. In general, a more reactive element displaces a less reactive element from its compound. This is actually its, it is its compound. Next, here you can see one more example. Copper sulfate CuSO4 plus iron gives rise to ferrous sulfate plus copper. In this beaker we have taken copper sulfate solution and we have dipped iron nail in this copper sulfate solution. Please identify the color here. The color of copper sulfate is blue and we have dipped iron nail in this. So iron reacts with copper sulfate and after few hours you can see that a brown layer is, this iron nail is coated with brown layer and the color of the solution is turning greenish. So can you guess what has taken place here? Yeah, this brown powdery deposition is nothing but copper. We know iron has come, it has displaced copper from its place. So that copper has occupied, that is forming a layer on the iron nail. And the solution is turning slowly greenish because it is no more copper sulfate. Now it has become ferrous sulfate. Few examples here which will be really very helpful for you for the practice in your exam, children. So please do write down these reactions and practice it regularly. It will be really very helpful. Copper sulfate reacts with zinc and gives rise to zinc sulfate and copper. Displacement reaction. Take one more example. Copper sulfate reacts with iron, or iron reacts with copper sulfate and displaces copper and it forms ferrous sulfate and copper. Then copper chloride and lead. These are the two reactants. Lead displaces copper and it forms lead chloride and copper. Silver nitrate and copper. So copper is more reactive than silver. So copper can displace silver from its place and it forms copper nitrate and silver. Cupric nitrate and silver. Iron reacts with hydrochloric acid and it forms ferrous chloride and hydrogen gas is liberated. Iron is displacing hydrogen. Magnesium reacts with hydrochloric acid and it gives rise to magnesium chloride and hydrogen. Sodium reacts with water and it forms sodium hydroxide and sodium is displacing hydrogen and therefore we get the hydrogen gas in all these reactions. In all these reactions, these elements are displacing hydrogen. Now let us move on for the next type of reaction, double displacement reaction. Double displacement reaction is a reaction in which there is exchange. Observe here, exchange of atoms or ions. So here there is exchanging. So the atoms or ions are getting exchanged here. So first one here you can observe, this is silver nitrate, this is potassium chloride. So here chlorine is leaving this and it is combining with silver. Chlorine, silver combining and potassium is combining with NO3, potassium nitrate. Potassium is combining with nitrate here and it is forming potassium nitrate. So here this is an example for displacement reaction. Here PbNO3 and potassium iodide. So here we have taken two compounds. One is lead nitrate and another one is potassium iodide. So when these two compounds combine together, there will be exchange of atoms or ions and it can form lead iodide and potassium nitrate. Let us consider this example. See here, two beakers are there. In one beaker, we have taken lead nitrate. Here, lead nitrate, potassium iodide before mixing. Before mixing will be lead nitrate and potassium iodide. Just now it has been mixed. We are getting yellow precipitate. This yellow precipitate is nothing but lead iodide. And what is left over, that watery, which after some time this will yellow precipitate will settle down and we get colorless liquid, that is potassium nitrate. So this is an example for displacement reaction. Two beakers, both the beakers has colorless liquid, lead nitrate and potassium iodide. So after mixing we get the lead iodide yellow precipitate and potassium nitrate. So this is an example for displacement reaction, and this is also an example for precipitation reaction, which you will be learning in your coming classes. Here again one more example for double displacement reaction. Silver nitrate reacts with sodium chloride and gives rise to silver chloride and sodium nitrate. Here you can see sodium is leaving its place and it is occupying the place here, and silver is occupying the place of sodium. So here there is exchanging. So this is an example for double displacement reaction. One more example here. Silver nitrate is taken in one beaker. Sodium chloride is taken in another beaker. Same reaction with the help of this picture. Here when you mix this, what happens is silver chloride settles and sodium nitrate will remain in an aqueous solution form. Few more examples for double displacement reaction. Silver nitrate combines with sodium chloride and there will be displacement, exchange of atoms or ions, and it forms silver chloride and sodium nitrate. Barium chloride BaCl2 reacts with sodium sulfate and it forms barium sulfate, which again forms a white precipitate, and sodium chloride is formed in aqueous solution form is obtained. Barium chloride BaCl2 reacts with copper sulfate and gives rise to barium sulfate and copper chloride. Copper sulfate reacts with hydrogen sulfide gas and it forms copper sulfide and sulfuric acid H2SO4. All these are examples for double displacement reaction. Again one more example. Aluminium chloride reacts with ammonium hydroxide and gives rise to aluminium hydroxide and ammonium chloride. Lead nitrate plus potassium iodide gives rise to lead iodide and potassium nitrate. Dear students, please do write down these examples and practice these equations and practice. As you practice, it will be very helpful for you. It will help you to easily understand and you become perfect in writing the reactions. Sodium hydroxide reacts with hydrochloric acid and forms sodium chloride and water. So this is also an example for neutralization reaction. This is an example for neutralization reaction also that you will be learning in your coming classes. So precipitation reaction is also an example for double displacement reaction. Neutralization reaction is also an example for double displacement reaction. So one more, I told you that how to remember the reactivity series. So potassium, sodium, calcium, magnesium, aluminum, carbon is added here. Zinc, iron, tin, lead, hydrogen, copper, silver, gold. So you can write down this and you can remember this sentence. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. If you remember these sentence, please stop calling me a careless zebra. Instead, try learning how copper saves gold. This one sentence, if you remember, you can write P for potassium, S for sodium, calling, Ca for calcium, Me for magnesium, A for aluminium, carbon, Z for zinc, I for iron, T for tin, L for lead, H hydrogen, C copper, then saves silver, gold is gold. So the one which is above is more reactive. As you come down and down and down, it becomes least reactive. Now the next one is oxidation reaction. What is oxidation reaction? The addition of oxygen to a substance is called oxidation reaction. If oxygen is added to the substance, that is oxidation reaction. Or if hydrogen is removed from a substance, then also it is called as oxidation reaction. So oxidation reaction is a reaction in which there is addition of oxygen or removal of hydrogen. The next type of reaction is reduction. So reduction reaction is a reaction in which there is addition of hydrogen and removal of oxygen. This is exactly opposite to one another. Oxidation is addition of oxygen. Reduction is removal of oxygen. Oxidation is removal of hydrogen. Reduction is addition of hydrogen. It is obvious from the above definitions that the process of reduction is just the opposite of oxidation. Moreover, oxidation and reduction occur together because these reactions generally happen together. If one is getting oxidation, another one element should get reduced. One molecule gets oxidized, another one should get reduced. So this go hand in hand. Let us learn more about this. Understand more about this. Can you identify the element here? Iron. Iron is here. Yes. Iron, oxygen. So here iron atoms, oxygen is here. So what is happening is oxygen is coming and here it is adding on iron. So here oxidation. This is a simple picture representation of oxidation. So oxygen is added to iron here. So this is what is called as oxidation reaction. Here you can see iron oxide. So here already it is oxidized, as you have seen in the previous one. Oxygen was added to iron and it became iron oxide. Now here what is happening is carbon is there. So here it is carbon. Observe this carefully. This is iron oxide. Here we have carbon. So what is happening? Oxygen is leaving iron and it is coming and attaching to carbon. Now it has become carbon dioxide. So who has lost the oxygen here? Yeah, now oxygen is with iron, right? So slowly what happens? Oxygen is coming away from iron. Iron is losing the oxygen. So if iron is losing the oxygen, so what is happening to iron? Iron is getting reduced. So what is getting oxidized? Carbon. Carbon is getting the oxygen. Addition of oxygen. Oxygen is added to carbon, so it is getting oxidized. So this is oxidation reaction and this was reduction reaction. If there is loss of oxygen, it is reduction. If there is gain of oxygen, it is called as oxidation. See, now oxidation is taking place. Carbon is getting oxidized. Iron has reduced here. Few more examples for oxidation and reduction. Copper oxide and hydrogen. So when these two combine, what happens? Copper and water is formed. So copper oxide. Copper had oxygen with it. So in the product, what has happened? Copper has lost the oxygen. So what has happened to copper? Copper has reduced. Here hydrogen didn't had any oxygen, but in the product hydrogen has gained the oxygen. So hydrogen has oxidized. Hydrogen is oxidized to become water. Copper oxide is reduced to copper. So here both oxidation and reduction is taking place. One more example, H2S plus Cl2 gives rise to sulfur and 2HCl. Here you have to observe for hydrogen. Here sulfur is having hydrogen with it, but in the product what has happened? Sulfur has lost the hydrogen. If there is loss of hydrogen, it is called as reduction. So sulfur has reduced. So to HCl. Chlorine has got, what has happened to chlorine here? Sulfur has lost the hydrogen. Sorry, sulfur has lost the hydrogen, so it has got oxidized. So chlorine has gained the hydrogen, so it has got reduced. Let us take one more example. Zinc oxide plus carbon. So here zinc is associated with oxygen, but in the product zinc has lost the oxygen, so it has got reduced, whereas carbon has gained the oxygen, so it has got oxidized. Carbon is oxidized to carbon monoxide. Zinc oxide is reduced to zinc. Here one more example. Manganese dioxide plus hydrochloric acid gives rise to manganese chloride and chlorine and water. Here you can see manganese is associated with oxygen, but here it has lost its oxygen, so manganese has reduced, whereas chlorine, here you can see hydrogen chloride, so here chlorine has lost the hydrogen. So if there is loss of hydrogen, what do you call it? It is oxidized. And in the same way, here hydrogen has gained the oxygen, so it is oxidized. So H2, here hydrogen has oxidized and manganese is reduced. One more example, copper oxygen gives rise to copper oxide, cuprous oxide. So here copper is gaining the oxygen, so it is oxidized. Oxidation reaction has taken place here. Again here you can see copper oxide reacts with hydrogen and gives rise to copper and water. Here you can see here copper oxide is reduced to copper and hydrogen is oxidized to H2O. Now that's it for now, children. We have learned in today's class, we have learned about combination reaction, decomposition reaction, displacement reaction and double displacement reaction, oxidation and reduction reaction. So let us take some homework question now. Identify the following types of chemical reaction and name it. Here I am going to give you some chemical reaction. You need to identify which type of chemical reaction is it. Out of 5, it belongs to which type of chemical reaction, whether it is combination or decomposition or displacement, double displacement or oxidation and reduction reaction, and you need to write it. First one, question. Second question, third, fourth, fifth. Pause and please note down these questions. Manganese dioxide reacts with HCl, gives rise to manganese chloride plus chlorine plus water. Sodium hydroxide plus HCl gives rise to sodium chloride and water. Copper oxide plus hydrogen gives rise to copper and water. Barium chloride plus Na2SO4 sodium sulfate gives rise to barium sulfate and sodium chloride. Copper sulfate plus iron gives rise to iron sulfate and copper. Lead nitrate gives rise to lead oxide plus nitrogen dioxide and oxygen. Hydrogen plus chlorine gives rise to hydrochloric acid. Zinc oxide plus carbon gives rise to zinc plus carbon monoxide. Carbon plus oxygen gives rise to carbon dioxide. Here I have given you 8 questions. So do identify which it belongs to which type of chemical reaction and write it. And one more interesting question. Let me see how nicely you will present your model. So make a model to show electrolysis of water using the material shown in the given image. I think you can easily get these materials at home. You have a pencil, battery and transparent glass. Try to take any transparent glass, plastic glass, or any transparent glass or cup, and come on, get ready and try to do the model to show electrolysis of water. One example already I have shown you in the video. Yes, come on children. Thank you. Have a nice day.